Okay, today we kind of did quite a bit of analysis on this R of t function, 2 cosine ti plus 3 sine tj. Of course, as we saw previously when we were talking about parametric equations, we know that this is going to give us, that this vector function is going to trace out an ellipse, and the ellipse will look something like this. An axis, a semi-axis, centered at the origin, semi-axis of 2, it's getting late, semi-axis of 2 on the x-axis, semi-axis of 3 on the y. Okay, so we know that. Okay, well, what we want to do is we want to look ultimately at the components of the acceleration vector in our direction of motion at any instant. We want to solve that then for a general time t, general value t of our parameter. If t is not time, well, that's okay too. That's the interpretation we're probably going to think in terms of for right now. Okay, so v is going to be your derivative of your r of t function, and a is going to be the derivative of your v function, which is the second derivative of your r function. And those derivatives are straightforward. I'm not going to read them to you. You know what they are. You got them. If you're in my class, you got them very easily, and you got them correctly. Okay, so note a couple of things. The magnitude of your r vector is 4 cosine squared t plus 9 sine squared t. Okay, and that's just obtained easily by the Pythagorean identity. Square this, that gives you your 4 cosine squared t. Square this, you get 9 sine squared t. The magnitude of this vector is 4 sine squared t plus 9 cosine squared t. So the cosine would be a sine, the sine would be a cosine if you wanted to get the magnitude of v. Then when you get a, the magnitude of a turns out to be exactly the same as the magnitude of r. So, and there are reasons for that, but we won't get into the analysis of the kinematics of the thing. We just want to illustrate these components. Okay, so we want to find the angle between v and x and the angle between a and b. Now, I did some stuff in my head over here, and I left it up there just so you can see how badly my head was working this morning. Okay, now we did it more systematically here, and we found that the cosine of theta 1 is the dot product, and of course the dot product of this and this, of the r vector and the v vector, is this times this plus this times this. Each one gives you a cosine times a sine. You have a negative 4 on this one and a 9 on this one. It gives you 5 times the cosine of t times the sine of t. And then the magnitudes of the v and r vectors are, just as I said, here's the magnitude of the r vector, and the magnitude of the v vector, you're going to have a sine with the 4 and a cosine with the 9. Okay, so that gets a little more complicated, and we multiply it out, and we're going to do that. But that's basically it. Now, why is that the cosine of theta 1? Theta 1 being implicitly the angle between r and v. Well, it's because of the definition of the dot product. Okay, the cosine of theta is a dot b over magnitude of a times magnitude of b. Now, people were trying to remember what the expression was for the cosine of theta. That's okay. If you've been doing a lot of it, you're probably going to remember it. If you've done as much as I have, you're probably not going to forget it until your brain gets fried, which is probably soon in my case. Okay, so you start from the definition, and it's a very easy rearrangement to find theta or cosine theta. And so we rearrange this definition to find cosine theta. We find it's the dot product divided by the product of the two magnitudes. Okay, well, then we multiply out the expressions under the square root signs. We effectively put it all under one square root sign and multiply this binomial by this binomial, and we can certainly do that. And oh man, that's a second piece of chalk I've broken in the last few minutes. So we wonder if I never have white chalk. Okay. So when multiplying it out, I believe this is probably correct. And this part here compresses because these are like terms to 97 sine squared t cosine squared t. And we don't want to belabor that, we know that. And then we get the cosine of theta 2, and the dot product here is just going to be negative cosine t sine t. The denominator is going to be the same, and then we go on. Okay, so that's the calculation of the cosines of the two angles.